Hello everyone, welcome to Pepcoding. So in this video, we are going to discuss another problem of our stack module, which is next number of recent calls. So firstly, we discuss the question, then we move to our approach. So let's see the question, what they are given in question. So you have a recent counter class which counts the number of recent requests within a certain time frame. So what does this line mean? We have a class recent counter, you can see here, and that counts number of requests which come in a certain time frame. Let's see, we have 0 to t time frame. So in this time frame, how many calls come? Like 1, 2, 3, 4. All these calls are counted and then it return these calls. Okay, now let's see what they are given in the next line. Implement the recent counter class. Okay, so in this we have recent counter function, or we can say that in recent counter constructor which initialize the counter with 0 recent request. So this is the recent counter constructor which initialize the counters with 0 recent request. Okay, now we have a int function, int type, return type function, ping. This is the function. Okay, int type ping function, and they are saying adds a new request at time t. So what does it do? It adds the request. This function works like it adds the request which come at time t, where t presents some time in milliseconds. So this t, this one, I'm highlighting this t. Okay, this t, this one represents some time in milliseconds and return the number of requests that has happened in the past 3000 milliseconds, including the new request. Okay, so it's a range from which I will erase it. So the range, I will say, range is t minus 3000 to t. So the range is 3 minus t2. So if we have 5 minus 3000 and 5, so if we minus this one, 2995 to 5. So between this time interval, how many requests come? It count the request and return them. The work of this function is that. Okay, now see the more. Specifically return the number of requests that have happened in the inclusive range of t minus 3000 to t. So that's same thing I write here in the whiteboard. And the last line, they are saying it is guaranteed that every call to ping uses a strictly larger value of t than the previous value. So meaning of this line is, if we have previous value of t is 5, then the next one will be 6 or maybe 7 or more than 5. This is the meaning of that line they are saying at the end. Okay, now see the input output. So the input, they are giving us sample input. They are giving 100, 3001, 3002. So this is the timing times t, value of t in milliseconds at which requests are come. For that, sample output is 1, 2, 3, 4. Okay, now move to our whiteboard and discuss our approach. So in this question, what they are given, I am writing, we have a t minus 3000 range. Okay, range of time, or you can say the range of count request, and we have function ping int t, and t is time in milliseconds. What I am doing, I am taking some example of time in milliseconds so that you can understand easily what we have to do in this question. Okay, now you can see In first we have, let's suppose I take this is time in millisecond, and here I take requests, number of requests. Now you can see I suppose we have request at 1 time in milliseconds. So the formula is 1 minus 3000 and 1. So we have minus 299 and 1. So 1 come between this range. So we have request 1. Now let's see. So I take example 100. So the answer is 100 minus 3000 and 100. We get minus 2900 and 100 and 29 and 100. So 1 comes in this range, and 100 it's include 100 also. You can see this one here, this line here. Request that has happened in the past 3000 milliseconds and including the new request. Same thing we write, so we take 2 here, 1 this one and second this one. Okay, now take more example. Now I write 200 minus 3000, we get minus 2800 and 200. So 1 and 100 both come in this range. So we write what we write. We write 200 here, and our request become 1 2 3 1 2 3. Now we take a bigger example, 3001 minus 3000. So we 1 2 3001. So 1 come in this range, 100 also come, 200 also come. So for 3001 we have 4 requests, 1 2 3 and its on 4. Okay, now I hope you understand how to calculate the number of requests over time. So now what we do, let's talk about a constant, what they are given in our each test case will call ping with strictly increasing value of t, and same thing they are writing here, larger value of t than the previous call. So you can see here in our at our whiteboard, you can see firstly the value of t is 1, then we have 100, then we have 200, then we have 301. Okay, so it's increasing. So 100 is greater than the previous one, then 200 is greater than previous one, then 300 is greater than previous one. I hope you understand the meaning of this line. Now you can see here one thing, if we take 3004, then we get our range from 4 to 3004. So in this range, the 4 come here, 4 comes here. So 1 didn't come, what 1 does not come in this range. So what we do, we neglect this one, or we didn't include this request in our answer request. So we have 4, because why we have 4 requests, you can see here. This one is neglected. So 1 2 3 4. So we have 4 requests. Okay, now for largest, like the previous, the current time is larger than the previous one, you can see here. For first one, what we have minus 299 and 1. Okay, for the second one we have minus 2900 and 100. For the third one we have minus 2880 and 200. And for the fourth one we have 1 and 3001. You can see here value is 299, but here value is minus 2900, is minus 2999. So you can see this one is greater. This one is greater here. This one is greater. When we move forward, minus 2800 is greater than minus 2900. Here you can see one is greater than minus 200. Okay. Now I hope you understand the meaning of these lines and what we have to do in our question. So now we talk about how we make the solution, or how we find the solution for that one. We understand our approach. For that, what I do, let's see here. I create a data structure, and you can see how we can deal with our approach. So I am taking a data structure here. It may be linked list, it may be linked list, it may be stack or queue or anything, or array, maybe array. We can find out the properties or like qualities which we have to need. According to that, we decide what type of data structure is it. So let's see. Firstly, we have one. So for one, what we are doing, we are adding one here, and for that one, how many requests we have? One. Then we have 100. So for 100, how many requests we have? 2. Then we have 200. For 200, how many requests we have? 3. Okay. Now we have 3001. I take 4 here instead of 1 so that you can easily understand. Then we have 3004. For 3004, what we are doing? We are neglecting this one. Okay. Because this one didn't come in our range. So again we have number of requests become 1, 2, 3. So we write 3 here. Now let's take our, and we understand that our time is in increasing order. Let's suppose I take a bigger one here. I take 4000. For that one, range becomes 1000 to 4000. For that, we have to remove these two also, because these didn't come in the range from 1000 to 4. So we have, how many steps we have? 1, 2, 1 and 2. So how many requests we have? 2. So I am removing these from our stack, also these from our. So we have only 2 requests. Okay. Now let's see, when we are increasing, when we are moving forward, our T is increasing and we are removing the older ones. So we don't have need of previous ones, and we are increasing. So you can see we are adding from the last and removing from the front. So the one come first and out first. First in, first out. So you can see this property is related to Q. So we can use Q here for our approach or for our solution. So that when we have one didn't come in this range from 304. So we remove 1 from here. Then we have, after removing 1, we have 100 at first, then 200. When 4000 come, we remove 4 here, 100 from here. So we remove 100 and 200 from here. Okay. So I hope you understand why we are taking Q and why we are removing, because our time in increasing order, T is always greater than T next is always greater than the previous one. I am writing this here. Why we are removing from the stack? Because from the queue, because T next value is always greater than the T previous value. That's why we are removing, because we didn't need this. and we take Q as data structure because these properties first in first out is similar to our Q. So I hope you understand what we write here, what's our approach, and what we have to need in our code. So let's move to our editor. I'm writing this again. In the editor, what they are given, we have a construct class, this one. What I am doing, I am firstly creating our queue. So I am creating queue of integer type is capital, integer type, giving it name queue. Okay, this is our new queue. Then we have a size, int size equals to 3000. You can see this thing here, 3000 milliseconds. Okay, now we have ping function. So I am completing writing here. Firstly, what we have to do, we have to add in queue. So we are adding t here. You can see here, when we have one, we firstly adding one in our queue. So same thing I am doing here, and then after that I am creating a min which is equals to t minus size. Why I am doing this, you can see we are checking the range. For that one we have to minus t minus 3000. Okay, then we check if or while q dot peak is less than min, then what we do q dot remove why I am doing this. You can see here, when one didn't come in the range of 3004, because the range is 4 to 3004, what we are doing, we are removing it from our queue. So if we have 3004, instead of t we have range from 4 which is greater than 1. Same thing we are doing here, we are checking if the q, the number which is present at the peak, is less than the q t minus size, then we remove it from our queue. And at the last, what we are doing, we are returning the size of q. Why we are returning the size of q? Because you can see here, for this one, before 4000, you can see this here, we have only for 3004 we have 3 requests, 1 2 3 requests, and this is the size of queue, because in our queue we have only 3 elements. If we return size, we get number of requests. Okay, so trying to compile it and see is there any error or something wrong. So it's compiled successfully. You can see here we get output. In our output we have 1 2 3 1 2 3 and 3. You can see here, or in our sample output you can see same thing. So trying to submit it. So it submits successfully, 10 out of 10. So I hope you understand the question. So that's all about the video. If you have any doubt, please write in the comment section, like the video and subscribe our channel. Thank you for watching the video.